Merhaba. Today we're talking about graphing transformations. Make sure you got this handout before you start so you don't have to rewrite this all. And you know what? I'm going to make your day. We're already going to start off by crossing off two boxes. We're not going to worry about this box, about that negative sign. We're not going to worry about this one, about that B. Yay! All right, so let's jump into what we are worried about. If you have a negative number in front of your x, that's going to reflect it across the x-axis. In other words, if your graph looks like this, I know, super fancy, right? If you put a negative in front of that x, it's going to make it look like this. So I'm going to put it upside down. All right, this a, well, if your a is greater than 1, that'll make your graph narrower or thinner. If your a is between 0 and 1, so if it's a fraction between 0 and 1, it's going to get wider. Okay, ooh, and I forgot to point out, this is a vertex form, so where h and k are our vertex. All right, well, if h is positive, if you add h, you're going to, so that's a plus h, not th, plus h. You're going to translate or slide, whatever word you prefer, left. If you get a minus h, then you're going to translate or slide, whatever word you like, right. So those are separate. Okay, and last but not least, we have k. If you have a plus k, so not tk, but plus k, you're going to translate or slide up. If you have minus k, guess what? Yeah, you figured it out. You're going to translate, which is another word for slide, down. Not so bad, right? Okay, let's look at what we call our parent function. So this is y equals x squared. That's our parent function, meaning all these things we talked about up here are all compared to y equals x squared. So we're going to fill out a little bit of a chart. So a reminder, this is y equals x squared. All right, well, we can see, let's start in the middle. That point when x is 0, y is 0. When we go over to 1, when x is 1, y is 1. And remember, we have to mirror our points. So when x is negative 1, y is 1. When x is 2, y is 4. And when x is negative 2, y is 4. And to find the last one, it runs off this graph, but you just ask yourself, what is 3 squared? In other words, what's 3 times 3? That's 9. Well, negative 3 times negative 3 is also 9. So everything we talked about here about translating and reflecting and getting narrower and wider is all compared to this graph right here. So looking here, when I say graph using transformation, I should say predict the graph. Predict the graph. Okay, so let's look at what this looks like compared to y equals x squared. So I notice I've got a 2 in front. So let's look back at the top. That would be like having a equal to 2. Well, 2 is greater than 1. That means we can expect something that's narrower. So I'm going to make a note. Because of this, it's going to be narrower. Right? Then we have x minus 3. Let's look back at the top. So that'd be an h. Well, don't let this confuse you. Notice we have a minus 3, so we want to go to the right, since we have a minus sign, to the right 3. So this tells us we want to go to the right 3. Now, that's the only thing that's changed. Now normally I'd say, okay, we should graph it, but since it's getting narrower and wider, that's really hard to predict. So you know what I would do? In your calculator, graph this, see what happens, see if we got this right, see if it is narrower and if it's to the right 3. And I bet you'll find out that we were right. So to the right 3, that means that from the vertex, again we're comparing it to our parent function, our vertex should go over 1, 2, 3. And then I'm going to cheat and tell you some points. We're going to have a point at 4, 2 and at 2, 2. And there's another point at 5, 8, which should be right here, and a point at 1, 8. So I knew this because, honestly, I graphed it in my calculator. But at the very least, you should know where the vertex is because it just moved to the right 3. Getting narrower and wider does not affect your vertex. All right, let's see if we can do the next one. Ooh, next one's a little trickier. We got more going on. So notice this is really a -1 hiding out in front there. So since we have a negative number, let's look and see what happens. If we have a negative, we're going to reflect over the x-axis. So let's make a note of that. Reflect over x-axis. All right. I bet looking at our chart at the top, you can figure out, since we have a +5 here, I bet you can figure out what's going to happen. All right, hopefully you said it goes to the left 5. And then this +7 means we need to go up 7. So let's start by plotting our vertex. Our vertex started here, but we need to go to the left 5 and up 7. So left 1, 2, 3, 4, 5. And up 7. 1, 2, 3, 4, 5, 6, 7. Cool. Now if you notice, one of our points was 1, 1, right? Okay, but we said we need to reflect over the x-axis, which brings us right here to 1, -1. Then we need to go left 5. 1, 2, 3, 4, 5. And up 7. 1, 2, 3, 4, 5, 6, 7. Okay, another point was -1, 1. So that's here. We need to reflect it over the x-axis, which brings us here. Go left 5. 1, 2, 3, 4, 5. And up 7. 1, 2, 3, 4, 5, 6, 7. And you could keep doing this and it would graph the whole thing. So another point, I'm going to be lazy, I'm just going to tell you it's at -3, 3. And another point is at -7, 3. And there's our graph. Cool. Let's look at the back. Okay, this is a little different. We need to match the equation to the right graph. So again, let's look at what's happening. Since this is negative, it's going to reflect over the x-axis. So we need to reflect. So let's see if any of these we can knock out. Which one of these can we get rid of because it's not reflected over the x-axis? This one. That one's not reflected, so it can't be that one. Okay, since A is 1/4, we need to look at a graph that's kind of wider. So it's kind of hard to tell. This one's probably the only one that's wider, but let's double check. Since we have -3 there, our graph should go to the right 3. And since we have a -2, it should go down 2. So remember, the vertex of y = x² is in the middle. It needs to go to the right 3 and down 2. So that looks like it might be it. To the right 3, down 2. So this one should have gone to the right 3, down 2. It went up 2. So that one doesn't work because it went up 2 instead of down 2. Well, you know what? I'm going to say this one's got to be our answer because that one definitely looks wider, whereas this one I don't think is wider than y = x². All right, let's see if we can do one more. So A is 2/9. That's between 0 and 1. So that means our graph needs to be wider. And since we have +4, we know that we need to go to the left 4. So let's see. Uh-oh, this one went to the right 4. Can't be that. This one went to the left 4, so maybe. This one went to the left 4, maybe. This one went to the left 4. Okay. So here's another thing I want to point out is this one also can't be right because it was reflected. We don't want it to be reflected. So next, let's see which one of these looks like it got wider. Well, this one looks like it got wider. This one got narrower, and this one didn't change at all. So there's your answer. Okay, I want you to see if you can figure out H, I, and J by yourself or with a partner. And I'll give you a big hint. On H, really focus on this +2. That should really give away the answer. All right, best of luck. Let me know where I can help you.